All right, so we just went through the Web2 attack path using this diagram. What we're going to move on to is trying to understand what happened on the Web3 part, how exactly things went sideways. And for that, we have a special guest. He is an Anon user, and he's also very familiar with EVM development.
Hello.
To explain what exactly happened on the Web3 attack path, we do need to explain the design of the Safe wallet.
At a high level, the Safe is a smart contract wallet. So it is a smart contract that lives on chain, that exists as your identity on chain. And the way that it works is there is a single implementation of the Safe. And this implementation is the actual code that runs. And then when you want to create a new instance of a Safe account to use, you create a proxy which points to this implementation. And this sort of architecture exists as an optimization, basically to reduce the amount of code that lives on chain, because the proxy is very small and simple, and the implementation is very large. And it's easy to know that all of the proxies are pointing at the same implementation.
So you're saying, like, you know, of the, I don't know, a couple 100,000 multi-sig wallets that exist, they all point to the same implementation contract.
Yes, now know that there's multiple versions of the implementation. So all of the proxies out there, you have the ability to point it to a new implementation, which lets you upgrade to a newer version of the Safe smart contract wallet.
Right, so you're saying you can choose whichever version you want to be on.
Yes, and you can do this right through the UI.
Okay, so actually, since this podcast is called Explain Again, I'm going to try to explain what you just said in a way that somebody who isn't like super technical can understand, at least the way I understood it. Is that okay?
Yes.
Okay, so in the Bybit example, for example, we have signer 1, signer 2. Let's just assume there were 2 signers. And the way their smart wallet was designed was that both of them need to sign in order for any transaction to proceed. The multi-sig wallet owned by the 2 signers is a proxy contract, like X said. And what I did here is I put like a picture of a brain with holes in it to represent that. It's a very simple contract. It mostly just holds the funds. If any funds were to be moved or lost, the funds are in this wallet, what we call the multi-sig wallet, where the wallet essentially gets its information on what it should do, what rules to follow, is from pointing at another location or another contract called the implementation contract. And this contains the wallet logic. For example, like if 2 out of 2 signatures were provided, then execute the transaction. And this is how Safe can upgrade their wallet designs. So it's not static. That's why you have a very big brain here that does workouts. Is that roughly right?
Yeah, that sounds roughly right.
So moving on to what went wrong, the attacker basically managed to swap out the good contract, the one that did what you expected to do, with a malicious contract. And in the malicious contract, basically in one of its instructions, it says, sweep all the ETH out of this account, of this wallet.
As soon as they signed, the multi-sig owner signed a your transaction to switch out what the implementation is truly game over, because the malicious implementation can really do anything. Send money anywhere. You can transfer all the ERC20s that it owns out, make any calls. So yeah, it's game over as soon as your upgradable contract points to a malicious implementation.
Yeah. So if we kind of tie it to the Web2 part, tell us what happened. We have the malicious JavaScript here, which ultimately got served to the user. What happened?
Yeah, so we had some malicious JavaScript that was served from the backend of the safe servers. And this JavaScript very specifically targeted the Bybit multisig. And what it did was it changed the data that was going to be sent to the private keys to a malicious transaction. So the multisig owners thought that they were signing something different than what they actually signed.
I mean, should we be looking side-eye at the signers? Like, did they not check? Is it their fault? I mean, I don't think anything in crypto these days is entirely somebody's fault. There's so many attack paths and so much out there lurking. So like, how do we think about that? Did they just not have the tools? Can you say more about what the industry standard or what you're aware of is?
Yeah, it's really not easy to know how to check what you're signing. Usually, you want to look at your hardware wallet and see exactly what you're signing, because the hardware wallet displays it before signing, and then you have to press OK. I want to sign this. The problem is that what are you supposed to compare that against? How do you recreate and double check against what ultimately is shown on your hardware wallet? So,
well, I feel like, sometimes when I play around with the ledger, I turn on all those settings. I enable the more detailed view. And I feel like when I do, I just have to do a lot more clicking, but it lets me check more things. Would it have let me check? So in this particular case, the transaction they signed essentially said, change where you're pointing to a malicious, to a different implemented contract. That transaction or that message that was signed would have said it was a delegate call, right? So then in the field of transaction type, it would, as far as I understand, it would have shown 1 instead of 0, and 0 would be just a regular message to be signed. Like, wouldn't they have been able to see that in whatever wallet they were using?
yeah, so if they were using, say, a wallet like Rabby or MetaMask, it would definitely show the call that they're trying to make.
You mean a software wallet, like between the hardware wallet and the UI? If they used MetaMask or Rabby, they would see that.
Yes, MetaMask or Rabby displays that information, and it's really important to check what these software wallets show, because the software wallet kind of sits in between the app and the hardware wallet. And the app tells the software wallet what to sign, and then the software wallet will display that and then send it to the hardware wallet.
Yep.
I believe in this case, they may have used the direct ledger integration into Safe, which ultimately got removed because it gets rid of this intermediate level of security around and displaying the data very specifically that is going to be signed.
Right, right. Some people have said that, ultimately you should check, like even though you see more data in your software wallet that sits between your hardware wallet and the app, they could be compromised too. So would you agree that the gold standard would actually be to be able to know what you have to check against your hardware wallet?
That could work. I think there's a lot of trade-offs, and ultimately it's really not an easy problem to know what is going into your hardware wallet. I think the gold standard would be to have a hardware wallet that is powerful enough and expressive enough to show you very clearly on a large screen exactly what is going to be signed, and be able to have enough space to pull in APIs so that you can decode the raw transactions into human readable form.
Yeah.
And even use things like ENS so that you can, resolve addresses to human readable names. And ideally, you would also do a simulation right in the hardware wallet and show you the side effects of the transaction.
You're simulating in the wallet.
That's what I would consider the gold standard, is basically collapsing Tenderly into the hardware wallet.
Wow. Can you say more about Tenderly for just, simple explanation of what it is?
Tenderly is this service that lets you paste in a transaction hash, or it lets you simulate a possible transaction before sending it. And then you can see exactly what happens. And this is useful because you want to know all of the side effects of your transaction before you submit it. Really, before you sign it, you should know what the side effects are.
Does it have to be on your wallet? Couldn't you do it locally? Wouldn't running it locally would, offer the same amount of offline type local security promises, if not guarantees?
Yeah, you would just have to be worried about something that sits in between the two applications. So something that's sat between Tenderly and your hardware wallet that was able to intercept the information and modify it in some way.
Okay, cool. I wanted to very briefly rewind to what you said about loading ABIs into the hardware wallet to be able to decode and display transaction data. I recently found out that the Keystone actually has this ability. You would go download a list of ABIs and load it into an SD card, and then stick that into your device, which is pretty cool. I have not tried it out, but I'm very excited to maybe try it out. So one other visual aid I wanted to cover today is kind of to give people a mental model of what the different exploit pathways could be, and why at the end of the day checking your hardware wallet is the gold standard in terms of, like, if you're going to check one thing, here's why you have to check the hardware wallet. So I drew up this diagram to help create a more complete mental model for people who aren't thinking about security and protocol development all day long, to understand where the potential areas of attack might be. Because during the aftermath of the Bybit attack, there were a lot of suggestions on Twitter about what they should or should not have done. Some of them are actually, they're good practices to have 100%, but they were not relevant to the particular kill chain. So I wanted to walk through what I understand the entire flow could be, and where in the flow of a transaction an attacker might be able to exploit a signing process. And it's the first time you're looking at it, so please let me know where you'd like to supplement or if I'm understanding things wrongly. So we start from the kind of the pure intention. I'm an organization, or here's an organization with the very business operational intention of moving funds from a cold wallet to a hot wallet, which is exactly what happened in the Bybit situation. Then the finance person who is responsible for making sure, there are enough funds in their hot wallet working capital accounts will go to Safe using their transaction builder. It's just a very nice, clean UI to enter things like, oh, we want to transfer X amount of ETH to this address, the hot wallet address. And then finance person would send the URL of this created transaction, which hasn't been signed, to all of the signers. And what I put in a gray box here are all the things that a signer sees before they sign a transaction. First, after clicking on the URL, they'll see the Safe UI with transaction information. This is on their laptop. And as far as I understand, the common use case is not to connect your ledger directly to your hardware wallet, directly to the Safe UI, but through a browser wallet. It could be a MetaMask, it could be Rabby. In this case, this UI is Rabby. And if you zoom in real close, you can see you can connect your hardware wallets here. And this is also on the computer. After you have confirmed the transaction details, then you click OK, and then you go to your hardware wallet, which is where you want to verify details as well. After you do your signing, a signature is created, and then somehow simplifying things, the transaction is submitted to the blockchain. The parts of this flow that sit on Safe's cloud servers are both the transaction builder and the UI that a signer sees. Is my understanding correct so far?
Yes.
Okay. All right, cool. So the way I think about it as a hobbyist cybersecurity person is that, so there are many ways to get pwned. Number one is essentially what happened was Safe cloud servers were compromised. So what could have happened is that the transaction builder was compromised. That's one way things could have gone wrong. The other area where things could have gone wrong is in the Safe UI, which is exactly what happened in the Bybit situation. And you could say earlier, you say we can check your browser wallet, whether it's a Rabby or a MetaMask or any of the other browser wallets. But technically speaking, they could also become compromised. Is that right?
Yes.
And so, like, basically what happened in Bybit was that the cloud servers got pwned. What happened in July and October last year was pretty scary. So essentially, Radiant Capital and WazirX, it's clearer for Radiant Capital, less clear for WazirX, but they were victims of a situation where their signers' computer devices were compromised. And so while their devices received legitimate JavaScript from Safe servers, on device that JavaScript was then malformed or edited in order for them to sign a malicious transaction. One thing I wanted to point to is that a lot of people after Bybit transactions said, oh, that's why you should always use dedicated devices. Don't use the same device for regular browsing and for your signing. It wouldn't have helped Bybit. It would have helped these Radiant Capital and WazirX, but it wouldn't have helped Bybit because the JavaScript they received was malicious from Safe servers. Is there anything you'd like to comment on, X?
There's really a lot of different places where in the supply chain, it's possible to attack and steal a user's money. It is not easy to secure these systems.
Do you agree though, like at this point, the hardware wallet is the one thing we do trust and we believe is least prone to being compromised?
I would like to think so. I think that hardware wallets, there's some out there that definitely have put a lot of effort into making sure that they're secure, but it's definitely possible to build a hardware wallet that's not secure.
Yeah, yeah. And we know of some, especially older versions of some brands that are not secure. Even if the likelihood is low, for example, for some of these exploits, you do need to have physical access. It still remains a concern. So it does matter what hardware wallet you choose. So like, like barring, any other better place to focus your time, I feel like checking your hardware wallet remains our best strategy.
This is true.